Okay, let's give you guys some practice. So work out the volume underneath this surface in this specified region. So convert this into polar form and then integrate it. So do whatever you want, work out the volume, press pause and have a go. Okay, so to do this we need to understand our region, the region in which we're trying to integrate. So well, if you look at this, dy here, that would mean this, y equals something, and this x dx here would mean x equals something, and we need to understand what's going on here. So let's try and find the region. So this is x, y. Y equals x would be a diagonal line. This is y equals x, and we have no idea what's going on here. So let's just hang on, square both sides. So that would be y squared equals 2 minus x squared. Add x squared to both sides, so that would be y squared plus x squared equals 2. So but when you get to here, you should recognize that this is a circle of radius root 2. So you've got a circle of radius you've got a circle of radius root 2, and then it's saying looking at the dy, you're moving parallel to the y-axis, from the diagonal line to the circle, from the diagonal line to the circle, from the diagonal line to the circle, from the diagonal line to the circle. And then x, if you look at x, it's saying scan from x equals 0 to 1. Well, it's a diagonal line, so this must be 1. It's a diagonal line, so this must be 1. And then it's saying scan from x equals 0 to 1. So scan from x equals 0 to 1. So really you're scanning like this. You're looking at this region here, from here to the circle, from here to the circle, from here to the circle, from here to the circle. So you're looking at this region here. You're looking at this region here, from the line to the circle, from the line to the circle, from the line to the circle, from the line to the circle. Scan it from 0 to 1. So you're looking at this region here. Okay, so now convert into polar form. So hang on, let me just move this up, bear with me. Let me just move this up, bear with me. Okay, hang on. Okay, so now convert this into polar form. So in polar form, this thing here will then become this thing, and you have to stick an R in there. And then in polar form, you would put this into here. So that will then give you this. Put this into the y, so you get 2y here. And we need to figure out our limits of integration. So remember, the region that we're interested in is this region here. So in polar form, you're doing this. You're scanning from the origin, and you're moving in well, your angle increases all the way around here. But the thing is, we're moving along like this. We're moving along like this in this region here when you're working polar form. So the rate thinking, remember dr first, and then d theta. So it's going to be r equals something, and then theta equals something, and then theta equals something. And you're moving from a radius of 0 to a radius of root 2. Radius of 0 to radius of root 2. Radius of 0 to the radius of root 2. And then in terms of the angle, you're scanning from an angle of 45 degrees to an angle of 90 degrees. So you're scanning an angle of 45 degrees, which is pi over 4, to an angle of 90 degrees, which is pi over 2. So in polar form, it's this whole thing here. So now it's just a matter of integrating that. So integrating it would then give you, hang on, factor out the r here. So you're going to have this. You're going to have r here, and then merge this r with this r here. That will give you r squared. So now it's a matter of integrating this. So hang on. when you integrate it, this whole thing here is a constant. So when you integrate it with respect to r, this would be r to the power of 3 and then over 3, from 0 to root 2, from 0 to root 2. So now we can put root 2 into the r. That will then give us hang on, put root 2 into the r. That will then give us this whole thing here, and then you take away and then put 0 into here, which will be 0. So this whole thing here will then become this, and then now integrate it with respect to theta. Well, this here is a constant, so take it out. This constant here is exactly the same as this, just written differently. So hang on. So now it's just a matter of integrating this whole thing here with respect to theta. So when you integrate this, it will give you sine. Integrate this, it will give you negative 2 cos theta, and then put this into here, put this into here. That will then give you this. Hang on. So when you put 90 degrees into here, sine of 90 degrees is 1. So when you put pi over 2 into here, it would be 1. When you put pi over 2 into here, it would be 0. And then you take away, put this into here. Putting this into here. What is sine pi over 4? Well, pi over 4 is 45 degrees. So you've got to think of a right angle triangle. 1, 1. That's 45 degrees. And then this, using Pythagoras, this will have no choice but to be root 2. So sine of, where am I? Cos of, hang on. So hang on, let's start again here. This into here, that would give you 1. Put this into here, that will give you 0. And then put pi over 4 into here. So sine would be this thing here. So it would be 1 over root 2. 1 over root 2. And then you got a negative and this negative here. That will give it a positive. And then you put pi over 4 into here. Cos of pi over 4 would be this thing here. That would be 1 over root 2. But then you've got this 2 here, so that becomes this thing here. So that will then give you this. Well, think about it. It will then give you this whole thing here, and then it's just a matter of tidying this whole thing up to give you this. So the final answer is this thing here. The volume is given by this. Okay.